An MCP server is more than a running process. It initializes a relationship, advertises clear capabilities, and sets boundaries so AI clients can discover tools, resources, and prompts, then use them safely, predictably, and with the right level of control. We've already established the foundation. MCP lets AI clients reach external context and actions through servers, and those servers can live inside real production architectures. Now we're focusing on a critical handoff: how a server tells a client what it can do. That discovery step is what makes reliable implementation possible. Think of an MCP server as an active participant, not just a collection of callable functions. The lifecycle begins when a client connects and initializes the relationship. During that handshake, the server advertises support for tools, resources, prompts, and behavior options. The client uses that metadata to discover valid operations and decide how to call them. From there, requests begin. Invoke a tool, read a resource, render a prompt, and receive either a response or a structured error. In production, this loop also needs versioning, permissions, monitoring, graceful shutdown, and safe change. Initialization is the moment the client and server agree on how they will work together. The client asks what the server supports. The server responds with details such as protocol version, server identity, and available features. That exchange lets the client choose only interactions the server actually understands. If a feature is missing, the client should adapt instead of failing later. In production, treat initialization as a real contract. Once capabilities are known, both sides enter a ready state with clear compatibility boundaries. Discovery works because the server advertises what it can do, instead of forcing the client to guess. Each capability needs useful metadata: a clear name, a plain language description, expected inputs, output shape, constraints, authentication needs, examples, and any side effects. AI clients use this information to choose the right capability and call it correctly. If the metadata is vague, the model may choose the wrong tool or misuse the right one. Strong capability advertisement makes integrations more reliable, safer, and easier to trust. Each MCP capability type answers a different question. A tool says, what can the client ask this server to do? That might mean creating a ticket, running a search, or updating a record, so permissions and side effects matter. A resource says, what information can the client read? It should be stable, inspectable, and safe to reference. A prompt says, how should this interaction be shaped? It packages reusable instructions for common workflows. The clean mental model is simple. Tools act, resources inform, prompts guide. Tools are where an MCP server stops being informational and starts taking action. That makes design discipline essential. A production-ready tool should have a clear purpose, a strict input schema, and validation that rejects bad or ambiguous requests before anything runs. It should also check authorization, document side effects, and return structured errors the model can reason about. Prefer small, intention-revealing tools like update record over broad do-anything tools. Narrow tools are easier to secure, test, observe, and recover from when something fails. Resources are the AI client's safe, addressable window into your system. A resource might be a document, customer record, log file, configuration entry, or knowledge base article. What matters is that each one has a predictable identifier, a clear title, a useful content type, and structured content the client can interpret. In production, reliability also means boundaries. The server should enforce who can read each resource, how fresh the data is, how large responses may be, and whether sensitive fields need filtering before they ever reach the model. Prompt templates turn one-off instructions into repeatable interaction patterns. When a team needs the same kind of work again, reuse the structure and change the variables: service name, time window, severity, customer, repository, or dataset. That keeps the request consistent while still adapting it to context. For an incident summary, the template should define required inputs and expected output sections, such as impact, timeline, root cause, and next actions. Good prompt design makes hidden assumptions visible, so results are easier to trust and compare. AI clients do not inspect your implementation before choosing what to use. They choose from the metadata you expose. Vague names like run query or process data force the model to guess, and guesses can lead to irrelevant or risky actions. Strong metadata narrows the choice. Use domain-specific, stable names. Describe when the capability should and should not be used, and make schemas enforce valid inputs. Add examples and expected outputs where helpful. This is not just cleaner documentation. It is better tool selection and more reliable behavior. Another important design choice is how wide a server's responsibility should be. A broad server gives clients one place to discover capabilities, which can feel simple at first. But it can also become a high-risk, hard-to-govern catch-all. Domain-specific servers usually scale better organizationally, because billing, support, infrastructure, and developer tools can evolve with their own owners and policies. Layered servers are useful when you need to wrap existing APIs or legacy platforms without disrupting ownership. The right boundary balances usability with security, deployment independence, performance, and accountability. Treat every exposed capability as part of your product's attack surface and operating contract. The question is not only, can the server do this? It is, should clients be allowed to rely on this? Before publishing, review access control, data sensitivity, side effects, failure modes, and abuse potential. Avoid exposing internal shortcuts just because they are convenient. Once a capability is live, manage it deliberately. Assign an owner, document expected behavior, version breaking changes, and deprecate with notice. Governance keeps useful capabilities available without letting the surface become chaotic, risky, or impossible to maintain. Capability descriptions are only useful if clients also understand what happens when things go wrong. A production system should return clear, structured errors, not vague failures. It should also advertise practical boundaries, timeouts, rate limits, pagination, and maximum result sizes. Just as important, responses should guide recovery, retry, or clarification. Behind the scenes, logs, metrics, and traces turn each call into operational evidence. Testing should answer the client's real question. Can I understand this server and use it safely? Start by inspecting advertised capabilities for clear names, complete descriptions, and consistent metadata. Then validate schemas with good, bad, and ambiguous inputs, making sure unsafe requests fail cleanly. Next, simulate realistic AI client choices. Which tool, resource, or prompt gets selected and why? Exercise errors, limits, and deprecations, so clients learn the right recovery path. Finally, keep regression tests around names, schemas, descriptions, logs, and traces, because small changes can affect discovery. You now have the core model for MCP servers: initialize, advertise capabilities, support discovery, handle invocations, and evolve safely. Tools perform actions, resources expose data, and prompts package reusable interaction patterns. The quality of your metadata determines whether clients choose correctly. Next, we'll turn this contract into code, then harden it for production.